In this video, I will consider one numerical on superposition theorem. Determine the voltage across 2 ohm resistor in the circuit shown below using superposition theorem. This is the given circuit. We need to find voltage across 2 ohm resistor. That is, here we have 2 ohm resistor. We need to find voltage across this 2 ohm resistor using superposition theorem. We know that in superposition theorem we need to consider one source at a time. Here we have 10 volt voltage source, 2 amp current source and 20 volt voltage source. That is, this circuit consists of 2 voltage sources and 1 current source. So here we need to consider one source at a time and we have to find individual voltage across 2 ohm resistor, and at the end we have to find the total voltage across 2 ohm resistor. So in first case, I will consider 10 volt source alone. When we consider 10 volt source alone, all current source in the circuit will be open circuited and voltage sources will be short circuited. So if we consider 10 volt source alone, this current source will be open circuited and this will be short circuited. Let me draw the equivalent circuit. That is, consider 10 volt source alone. So here there was a current source that is open. When it is open, it will become open. That is, this is open, and here the 20 volt source is short circuited. That is short circuited. This is the equivalent circuit when we consider 10 volt source alone. Now let me find the voltage across 2 ohm resistor. That I will call it as V1. That is, so I will solve this using loop analysis. Let current through this loop is say X. Let current through this loop is Y. Let me apply KVL to first loop. That is, 10 is equal to voltage across this is 10x plus voltage across this is 20. So x and y are flowing opposite to each other. So it is x minus y. That is, 10 is equal to 10x plus 20x minus 20y, or 10 is equal to 30x minus 20y. Let me call it as equation 1. Similarly, apply KVL to second loop. We can write 0 is equal to, as there is no any voltage source in this loop, so it is 0 is equal to, this is 2y, voltage across this is plus 5y, plus voltage across 20 ohm is 20y minus x. Let me simplify this, or I can write 2y plus 5y plus 20y minus 20x, or I can write 0 equal to minus 20x. This is 2 plus 5, 7 plus 20, that is plus 27y. Let me call it as equation 1. Now we need to find equation 1 and 2 to calculate the value of x and y. That is, solving equation 1 and 2. Let me solve this using directly calculator. So go to the mode, choose equation mode. In equation mode we have only two unknowns, so choose the equation 1. So here a is with respect to coefficient of x, that is 30. Then coefficient of y is minus 20. Then this value c is nothing but this voltage value, that is 10. So second row indicates the second equation values, that is coefficient of x is minus 20. We have minus 20 equal to, we have 27. This is 27. Then this value is 0. Press equal. The first value is x, which is 0.6585. So I can write x equal to 0.6585 amps, and we have y is equal to 0.4878. Y is equal to 0.4878 amps. So now let me calculate the current through 2 ohm resistor. So in 2 ohm resistor current Y is flowing, therefore voltage across this, the current in this 2 ohm resistor flowing like this end will be positive, this end will be negative, so this will be V1. So I can write V1 will be equal to 2Y, that is 2 into 0.4878, which is equal to, we have 2 into 0.4878, 0.4878, so it gives 0.9756, 0.9756. So therefore V1 is equal to 0.9756. Now I will consider 20 volt source alone. In that case, this will be open circuited and this 10 volt source will be short circuited. Let me consider 20 volt source alone. So consider 20 volt source alone. So the circuit looks like this. Here there was a current source which is open. Here there was a voltage source which is shorted. So here we have 2 ohm resistor. Now I will assume voltage across this 2 ohm resistor is V2. Let this is V2. We have to find V2. So now let the current is flowing in this loop is I. Here we can see that these two resistors are in parallel. That is, I can find R is equal to 10 is parallel with 20. So let me calculate its value. That is 10 into 20 divided by 30. That is nothing but 200 by 30. That is nothing but 6.667. So let me draw the equivalent circuit. I can draw the equivalent circuit here as this is 6.667 and here we have 2 ohm resistor. This is 2 ohm resistor and here we have 5 ohm resistor and this is 20 volt. So let me assume current in this loop is I. So here we can see that all these resistors are same. The current flows through in all these resistors is same. So I can directly find current as, that is current I is equal to, we have 20 divided by sum of these three, that is 5 plus 2 plus 6, that is 5 plus 2 is 7, 7 plus 6, that is 13.667. So let me calculate this. Here we have 20 divided by 13.667, so it gives 1.46. so this current is 1.46. Now here we can see that current is flowing in this direction. It means this end is positive, this end is negative. So let me call V2 is equal to, we have 2 into 1.46, 2 into 1.46, which is equal to, so this into 2, so it gives 2.92, 2.92. So now here we can observe that here V1 is, this end is positive, this end is negative. So here in V2 this end is positive, this end is negative. So I will consider all directions are same. So I can write V2 is equal to, if we assume current is flowing in opposite direction, it will be minus 2.92 volts. So we should consider in superposition theorem, we should consider all directions are same. So here we have taken opposite. So if it is current is flowing in opposite direction, then definitely it will be minus. Two amp alone. So here voltage source is short circuited, here voltage source is short circuited. Now here we can observe that these two resistors are in parallel. So already we have calculated its equivalent value, that is 6.667. So let me draw the equivalent circuit. These two are in parallel. Its value will be 6.667. Here we have 2 ohm resistor and here if resistor is in series with current source, the resistor should be ignored. So I will ignore that 3 ohm. This will be 2 amp, and here we have 5 ohm resistor. It will be like this. So here it is 2 ohm. So now we can see that this 2 amp current will divide here. Part of the current will flow here, part of the current will flow here. Let me assume current through this branch is I1, this branch is I2. Now here directly I will apply current division rule and I will calculate I1. So I can write I1 is equal to, that is by applying current division rule, that is total current into opposite resistor. So here opposite resistor is 5 divided by sum of resistors. So sum of resistors means the current I1 is flowing between these two resistors, in these two resistors, and I2 is flowing in 5 ohm. So sum of these three, that is 7 plus 6, that is 13.667, which is nothing but 10 divided by 13.667. Therefore I1 is equal to 10 divided by 13.667. So it gives 0.73 amp. So therefore I will assume the voltage across this is say V3. Therefore V3 will be equal to, so this current will flow in this direction. So this end will be positive, this end will be negative. So therefore it is 2 into I1. So V3 will be equal to 2 into 0.7. So this into 2, it gives 1.46. That is 1.46. Here also we can observe that current is flowing in this direction. So this end is positive, this end is negative. So if I take this as a reference, this is positive, this is negative. Here this is positive, so I have taken it as negative. So here also it is same. So V3 will be minus 1.46. Now let me calculate the total voltage. So therefore total voltage across 2 ohm is V is equal to V1 plus V2 plus V3, or I can write V is equal to, so V1 is 0.9756, 0.9756. So V2 is minus 2.92, minus 2.92, and V3 is minus 1.46, minus 1.46. Therefore V is equal to, here we have 0.9756 minus 2.92 minus 1.46. So it gives minus 3.4. That is total voltage is minus 3.4 volts. So this is the voltage across 2 ohm resistor, which is solved using superposition theorem. Thank you for watching.